Hello everyone, welcome to Reactify Labs. Today we will study load balancing. So, what is load balancing? As the name suggests, it balances the load. Uh, it's very clear from the name, but still I will use an example. So, you went to a restaurant. You went to a restaurant. Okay. Let's say this restaurant is a very new restaurant, very new. It has just opened, nobody knows about it. You are the first customer. So, there comes a waiter to take your order. Waiter will take your order and go. Next, after you leave, another person comes. Person one. The same waiter comes and takes your order and leaves. Now, after obviously, when this person left, then person two comes. Again, the waiter comes, takes his order, serves him, everything happens. Now, slowly, restaurant became popular. Now, what happens is instead of having one person at a time, we have P1, P2, P3, P4, four people came together. And if there is only one waiter, it can obviously four people came together, but they all sat on separate tables. So basically, there are four groups. So this waiter will serve each of them one by one. It cannot serve them all together. So when this person is serving this person, when this waiter is serving this person, the others are waiting, right? So this is the problem with one waiter. Instead, what we can do is we can have two waiters. One waiter will take the order of this person, and after that this person, then what happens is for this person the waiting time is reduced. It's still some, but okay. And this waiter will cater to these two people. This waiter will cater to these two people, and this waiter will cater to these two people. This is one way, but it's not always the case. It is possible that we can have three waiters, we can have four waiters, and so if we have 10 people also, we can cater to them. So that's load balancing. So we are balancing the load of multiple people on different waiters. So that's why when you go to a restaurant, you see there are multiple waiters so that the load is evenly distributed among different waiters. Okay. But again, how will we decide how to distribute load to which waiter? We need to know, right, which waiter is free and which is not. So I'll talk about that later. Right now we understood what load balancing is using the example. Okay, it's very easy example, and the name suggests everything, so we don't even need that example, but okay, let's go into the technical definition. Load balancing is a method of it's a method of distributing load. Sorry, it's a method of distributing load, or in this case, network traffic. And how? Equally among whom? Across a pool of resources. Across a pool of resources that support an application. That support an application. Okay. Yes, the best technical example would be any system you can take: Facebook, WhatsApp, Instagram, Amazon, anything. Always it has millions of users, millions, or if not millions at one time, thousands of users at one time, right? So obviously one server cannot hold it, so we will have multiple servers and the load is distributed among these servers evenly so that all the requests can be handled properly, right? This is the best example in technical terms. So this is the definition of load balancing. And what are the key objectives of load balancing? The key objectives is, first one, obviously the even distribution. We do not want one server to be free and one server to be all occupied. So we want the even distribution of load. Since we have all the servers, we want all the servers to be occupied equally, and that is also called optimal resource utilization. Optimal resource utilization. You may ask, what is the difference between 1 and 2? One says that all the servers should have equal distribution of load, okay, so that one server is not overloaded. But second point says that, okay, if one server is not as loaded as the other, it means we are not utilizing our resource. But since we have server, we are already paying for it, and if we are paying for it and not using it, then we are fools, right? So we have to take care of the optimal resource utilization. And when we have multiple loads, when we had multiple waiters, it means waiters were available for all the people, and people get responses very quickly, and that's why comes high availability and reliability. High availability and reliability, right? So this is the definition of load balancing and why we need load balancing. But now we have why and what. Another question is how. It means we need to know how load balancing happens. So for that, the topic is load balancing strategies. Okay, what are the different strategies employed for load balancing? What are load balancing strategies? What do they do? They aim to evenly distribute requests among servers. Okay, their aim is to evenly distribute requests among servers. Okay, there are different strategies. Let me talk about all of them. So for that, let's consider one example. Okay, so assume we have 5 servers: 1, 2, 3, 4, and 5. Their names are server 1, server 2, server 3, server 4, and server 5. Okay, and we have 100 requests. Okay, and they are represented by numbers from 1 to 100, right? What we can do is, first approach that we can use is, instead of this, I'll write it here: 100 requests from 1 to 100. First approach can be round robin. Round robin. What round robin does is, it will do this: key 1 here, key 2 here, key 3, key 4, key 5. It's this request or key. Let's call it key. Okay. And sixth one will come here, seventh will come here, right? Eighth will come here. But the problem with this approach is that, what if this request, this request 1 was larger but 2 was smaller? It means when this 6 came, by the time this 6 turn came, 6 could go here because 2 would have finished by then. 2 would have been completed by then 6 could come here. But no, using the round robin approach, we put 6 here. Okay. So the problem with that is, 6 will keep waiting until the 1 is finished, even though we had 2 here which was already available, right? What if 7 is not available at the moment? It means 6 is still waiting for the server 1 to be empty, even though server 2 is empty, right? When 7 comes, 7 will go here, then that is fine. But the problem is, when again 8 comes, and by the time 8 comes, 5 is done. But again, 8 will not go here, 8 will go here. Okay, if 8 goes here, then again the problem is same. It has to wait until 3 finishes. What if 3 never finishes? 3 is very large, or 3 has some problems, 3 is stuck, 8 will never be serviced. So that is the drawback of this uh, approach. Okay, and once this happens, so what will happen is 9, 10, 11, 12, 13, 14, 15, they will keep coming. Again 6 and 11 will remain unprocessed, 13 will remain unprocessed, even though other servers may become empty, right? So this is the drawback with round robin. Next is, we have least connections method. We have least connections. Okay, so let's take this. Okay, now what happens is we assign a key to the server with fewest active connections. Okay, so in this, let's assume that at this point every server is like this. Okay, actually for simplicity let me take only two servers now. I have two servers, S1 and S2. Okay, what happens is we see that initially server 1 has 20 keys to serve and server 2 has 80 keys to serve. Okay, now let's say 10 new key comes 10 new keys comes. What happens in that case? All the 10 new keys will go here because this has low number of connections, least number of connections. It has only 20, it has 80, right? This is good. Again 10 keys come, they will go here. So they will keep going here until it has also 80 keys equal to that, because then when they become equal the call will be equal to both. But the problem is one, lack of information. The the servers assigning the keys to the servers don't know what is the processing power. What if it has a processing power of 1 Gbps and it has a processing power of 100 Gbps? It means this has only 4 times load. This has only 4 times load but 100 times power. So assigning new requests to this server does not make any sense. So these requests should go to this server. So that is the problem with least connections, right? I hope this clears the round robin and least connections. Another approach is called IP hashing. In this, what we do is, yes, we hash the IP addresses. IP address hashing. So let's say IP address is something IP1. The hash becomes IP1. Another IP address hash becomes IP1 again. Even if it's from a different location, let's say US hash, we do not know what hash will do, right? So hash US hash will become IP1. Australia hash also becomes IP2, IP1. Okay, and if multiple hashes become IP, same IP, it is possible that other hashes are free, other IPs are free. All these will go to same server. Let's say this go to server 1. Okay, even though other servers are empty, since the hash is giving us IP1, it will all go to server 1. That is the problem with IP hashing approach. Okay, so we saw that even IP hashing, round robin, least connections, nothing seemed to work. Then what works here? Then we have something called consistent hashing. Consistent hashing is a broad topic, so I'll make another video on this explaining what consistent hashing is and how it works. This video I will end just on the definition of consistent hashing. So it's a distributed hashing scheme that operates independently of the number of servers by assigning them a position on abstract circle or hash ring. It minimizes data redistribution while adding or removing servers, hashes keys onto a fixed size ring and maps them to servers based on their positions on the ring. The problem with other approaches is they have the fixed number of servers, right? So what if a request comes for this and it is not able to serve it at the moment, right? And what if the server is down? What happens in that case? What happens? The request comes here and the server is down. So the request will keep on accumulating here. The request will keep on accumulating here. Okay, there is possibility that it may go here, right? So okay, the request will come here, but what if it comes up again? It's active. Now what happens? We do not have any way to know that okay, this is active, and we do not have a way to dynamically balance the number of servers. So that is where the drawbacks of these other connections come in, and consistent hashing addresses all those. So just remember the definition for now. It's a distributed hashing scheme. Distributed hashing scheme that operates independently of the number of servers. I'll add more to this definition in the next video, but just assume this is the keyword. It operates independently of the number of servers. For others, we know that if you see the round robin, we already know that after 5 in the round robin, we knew that after 5 we have to come back here. But round robin, we should tell round robin that okay, we have only 5, right? In IP hashing also, if we have only 5 servers, then we know that if we have to hash the IP address, then we have to do a mod of 5, right? So that if it is 0, it comes here 1 2 3 4. But what if one server is down? Then we have to make it hash mod 4. What if we add one more server? Then we have to do it hash mod 6. And if we have to do, let's say, 4 or 6, then we have to reassign all these requests, which is again a troublesome task, which is not right for us. So all these problems are addressed by consistent hashing because it operates independently of the number of servers. Okay. If we have to just explain it more, it operates independently of the number of servers by that operates independently of the number of servers by assigning the keys a position on abstract circle. It is called an abstract circle. It's not an actual circle, it's just an abstract circle, or also called hash ring because it's a consistent hashing. This is a hash ring. Again, it's different from IP hashing. Here we do not use any number of servers, any mod. Okay, we use mod, but it is not dependent on the number of servers. Okay, it maps keys onto a fixed size ring. Each key is hashed onto a ring. I'm just talking theory here. I'll explain it in more details next. The benefit is minimal redistribution on server changes. Minimal redistribution on server changes. Even if server changes, as I told you, if instead of 5 we have 4 or 6, the redistribution will be very minimal. Minimal redistribution on server changes. It does balanced load distribution and has adaptability to changes. With changes in the number of servers, it adapts itself. Okay, so I'll just add one more thing. What are the advantages of this? What are the advantages of consistent hashing? Obviously, everything that I talked about here: minimal redistribution of load, balanced load distribution, and one more thing if I have to add, I'll say flexibility and scalability. It gives you the flexibility to independently add or remove any server that you want. It adapts to changes without disrupting existing mappings. Okay, so I hope this clears the concept of load balancing. This video focused mainly on the load balancing, how different approaches do the load balancing and why others don't work. Please do not worry about consistent hashing because I'll make another video about it. So that's it. Thank you for watching. Please remember to like, share and subscribe. I will see you in the next one.